All right, let's take the area of this shape. I've got the same setup as before, so r equals 1 minus sine 0.9 sine of theta. To still have it plotted on the screen here, I still have to have those x and y values, but I'm not going to be using them for the calculation, so I've got them kind of moved off to the side and grayed out. Let's say in this column I'm going to do the area of this circular sector. Remember, circular sector is a name for kind of a pie slice shaped thing. And then let's do the total area so far. Map that so we can see it. All right, so what do I want to say is the area of the circular sector that goes from theta equals 0 to theta equals 0.1 and has a radius of somewhere around 1 or somewhere around 0.9, something like that. Well, the formula is 1/2 times what? Times r squared. Let's just do the simple thing here and take that r and multiply by the distance, by the difference of the thetas. And we'll fill that down. And then the total area so far, we'll say if I start at theta equals 0 and go to theta equals 0, my total area so far is 0. And then on the next row, my total area so far is the previous total area so far plus the area of the circular sector I just had. And then I do that all the way down, and we get an answer of 4.36. Is that reasonable? What can we do with this graph to think about that? Well, we could count boxes. Each square here, sort of square, is 0.5 by 0.5, so it has an area of 0.25, 0.5 squared. And how many boxes are there total? Just roughly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus another like 13-ish here, plus maybe another 1 there, so 14, maybe plus another 1 there, 15. So what's 15 times 0.25? I'll say 0.5 squared, 3.75, and yeah, that's kind of close. What else can we do? We could get a lower bound, use the smallest radius we saw. So what is the smallest radius we saw? It's somewhere around there, pi over 2, so 0.1 is a radius. So we could say pi times 0.1 squared. I need to say pi like that. And then as an upper bound, use the largest radius we saw. So pi times, what's the largest radius we see here? It might be that 2, but let's go see these radii. Yeah, it never quite gets up to 2. Let's just use 2. So somewhere between those, and then our guess would be maybe half those. Okay, well, it's plausibly like the total area so far that we got. So we're reasonably happy. Here we had used the first radius of this sector. That's kind of like using the left-hand method, because when you're going left to right on the x-axis, the left side is the first one you come across. If I did this one instead, that would be like the right-hand method. And get about the same value there. And if I did the average of this one and that one, so average of those two, and then square that, that would be like the trapezoid method. And that would usually be a little more precise. In this case, we're getting all answers that are all pretty close to the same because we're taking a fairly fine grid of points. Next, we'll do some by hand calculus with integrals for area.